Very good morning to you all. I welcome you all to this webinar on Eurocode design and BIM using Midas Gen. So the flow of today's presentation is on your screens. First of all, I will be introducing you all to Midas Gen. Then we will see some of the RC design features. We will be covering the design of RC frame, the design of meshed slab, and then we will also cover the RC capacity design as per EC8. After that, we will see that how we can generate drawings using Dshop, and then we will see an additional tool of Midas Gen, which is known as General Section Designer. After that, we will see the interaction of Midas Gen with the Revit structures. Some of you may be new to Midas Gen, so first of all, I will like to introduce you all to the software. Midas Gen is a 3D FEM software for structure analysis as well as design. These are the four functionalities of Midas Gen which are very much liked by the users. First is the seismic specific functionality. The program supports the auto generation of the loads as well as design for the seismic conditions. Second is the comprehensive design. Midas Gen supports design of RC and steel elements as per a large number of codes. Design of SRC and footing is also supported. The slab and wall design is also supported as per Eurocode 2. So in order to design the slab and the wall, you need not interact with any other software. The design can be performed in Midas Gen itself. After that, the capacity design as per EC8 is also supported. Then the high-res specific functionality of the program is very advantageous. You can incorporate the effect of time-dependent material properties. Construction stage analysis can be performed. And then the intuitive user face is very much liked by the users. Users feel it very easy to learn the software and adapt to the software. So on your screens, you have the application areas of the program. The interface of the program has been optimized for buildings. You get a large number of results which are very quickly useful in the buildings. But the program is a general structure software. It can be applied to stadiums, power plants, hangars, airports, transmission towers, and other structures. The software has established its reliability as by application in a large number of the number of structures. So the program is all-in-one modeling, analysis, and design tool. So let's see some of the modeling features of the program. So the program supports import of AutoCAD DXF files. So if you have any structure in AutoCAD DXF format, then you can import the drawing in Midas Gen. Let's see how. So here we have a structure and we can import the structure to AutoCAD to Midas Gen. So the program has the database of materials. You can select any of the materials from here. So here we see that we were having a structure in AutoCAD DXF format and we have imported that structure successfully into Midas Gen, and it was very easy. Now let's see some of the general modeling procedures in Midas Gen. So here I have a file with the material and the section properties. Now let's see the general modeling procedure. So for the modeling of the frame structures, the program has a frame wizard. So you can very easily generate a frame You just need to enter the span information, and you need not enter each and every node individually. So here we see that we have the structure with us, the frame with us. Now we want the columns from the structure. So here we have the extrude option. We can extrude nodes to columns. So we'll enter just the very basic information and the structure will be created. And now we need to have the other stories above the first story. So we'll go to the building generation. Here we can enter the information. So above this, I want one story with height 3 meter, and above that I want two stories with height 2.8 meter, and then I want two more stories with the height 2.75 meter. So entering this information and applying, I have the structure generated with me. Here we can specify to convert the self weight into masses. And let's see the generation of the loads. So for the lateral loads, the program supports the auto generation of the wind loads as per Eurocodes. So for wind in X direction and similarly wind in Y direction. So entering the directional factors. So here we can see that the program has automatically generated the story force, story shear and overturning moment in the graphical form as well as in the Excel form. So here we also have a very detailed report in which the program details that how the wind load has been generated. So this is for the X direction and similarly for the Y direction, changing the directional factors. And then the static seismic loads. So for the static seismic loads, we have the auto generation of the static seismic loads as per Eurocode 8. So static seismic load in X direction, and similarly static seismic load in Y direction. So here similarly we have the seismic load profile, the story force, the story shear and the overturning moment. And now similarly we will generate the static seismic load for the Y direction as per Eurocode 8. Here I would like to mention that in the coming release of Midas Gen, the program will be supporting the auto generation of the wind loads as well as the seismic loads as per the Singapore National Annexure. So here you will be viewing the option of selecting the Singapore National Annexure from this May or June. Then let's see the response spectrum load cases. So the program has the database of response spectrum functions as per Eurocode 8. Similarly, response spectrum functions will also be added as per the Singapore National Annexure. So response spectrum load case in X direction, because X direction is the major mode direction here, and similarly in the Y direction. So excitation angle is 90 degrees. Here we can specify the number of frequencies to be used. So we have the structure with us. So you can see that how easily we have generated the structure and applied the loads as per the Eurocode specifications. Now let's move to design. So for the design of concrete, the program supports design of beam members, column members, and wall elements. The program also supports the meshed slab and meshed wall design. The capacity design is also supported as per Eurocode 8. So these are the design codes available at the moment. So RC design can be performed as per ACI codes, European codes, British codes, Indian codes, Canadian codes, and other country codes. Similarly, the steel design is also supported, and similarly footing and slab design. So this is the Eurocode implementation status. For materials, the program has the database of Eurocode 2 for concrete materials and the database of Eurocode 3 for the steel materials. The program supports the auto generation of the static wind, static seismic, and response spectrum functions as per the Eurocodes, as we have just seen in the previous model. Then for design, the program supports the auto generation of load combinations as per Eurocode 0. Both ultimate limit state as well as serviceability limit state design is available as per Eurocode 2 for concrete elements and as per Eurocode 3 for steel elements. Now let's see some of the design features for RC frames. So in order to have the design forces, we first need to specify that the frame is a braced frame or an unbraced frame in X and Y direction. So let's see how we can accomplish this in the program. So first of all, we will see that in design, we have general design parameter and the definition of frame. So here we can specify that the frame is a braced or an unbraced frame in both the directions. And similarly, we can specify that the program should auto calculate the effective length factors. So this information will be used in the magnification of the moments. Then we have the general design parameter. We have a member assignment option. Let's see how we can use the member assignment option. So if we see this beam, so in order to incorporate the connectivity of this sub beam, we have to divide this one member into two elements. So, but for design, we want to consider this member as a single element. So let's see how we can do this. So let's see how we can do this. In design, we have an option for member assignment. Here we can specify that what members or what elements should be chosen as one member for design. So it can be done by both manually as well as automatically. So let's see how. So here we have the option add replace, auto, and all. So as soon as I click on apply, the program detects that these two members should be considered as one for design. So they are highlighted, and similarly the other members have been detected. So here you can see that the members 716 and 717 have been detected to considered as one. Similarly the other members. Then we have to specify the unbraced length. So here you can see that for the member B, for bending about y-axis, the unbraced length should be used as L3, but for bending about z-axis, the unbraced length of the column should be used as the sum of L2 and L3. So if you have chosen the member assignment option, then this will be automatically taken by the program. If you haven't chosen the member assignment option, then this can be specified manually as well. Similarly for the lateral torsional buckling. So let's see how we can specify the unbraced lengths. So in design, general design parameter, we have option unbraced length. So if 0 is entered here, the program will automatically detect the unbraced lengths. Otherwise, you can specify the lengths manually. And if you do not want to consider the lateral torsional buckling, then you can just click on do not consider, and the lateral torsional buckling will not be considered in the design. Then we have the beam and offsets and the panel zone effect. So let's see what is the use of these two options. Now, if we closely observe this joint, then we have this member up to here and this member up to here. So these two members are meeting at this node, and similarly the other two members. But for design, we do not. But for design, we need not consider the movements in this part because they are a part of rigid zone. And for efficient design, we can cut the bending movements in this zone. So this can be taken care by two methods in the program. First is the beam and offset. So here you can specify manually that at what distance in the three axes you want to have the section for design, from which section you want to take the design movements, or else you can go for the panel zone effect. In the panel zone effect, if you specify that auto calculate the panel zone offset distances, then the program will automatically detect the sections from where the design movements should be taken. Then we have the RC design sections. For the design of beams, the program supports the rectangular beams as well as the flanged beams. For the design of columns, the program supports the rectangular sections as well as the circular sections. The circular sections are supported for both spirally reinforced as well as the tied reinforcement, and both the hollow circular sections as well as the filled circular sections are supported. For the design of walls, the rectangular section is supported. Now for design, we need the load combinations. So the program supports the auto generation of the load combinations. So in results, we have combinations. We have various tabs here: general tab, steel design tab, concrete design tab. So here let's see the auto generation of the load combinations. So here we have the auto generation, and we can select the design code according to which we want to generate the load combinations. So here also the Singapore National Annex will be supported by the program. So we can just click on apply and the load combinations are auto generated. We can also have the load combinations in the form of spreadsheet. So we can enter these and modify these combinations manually very easily. Now after that we have the load combination type and serviceability parameter. So first we have the short or long-term load case. So here the program classifies the load cases as the long-term or the short-term. So the stresses from the long-term load cases will be compared with the stresses that are allowable for the I'm sorry. So the long-term allowable stresses will be compared with the stresses from the long-term load cases, and the short-term allowable stresses will be compared with the stresses from the short-term load cases. And then we have the serviceability load combination type. As I mentioned that the program supports the serviceability checks also. So for that we need to classify the load combinations as quasi-permanent, frequent, or as characteristic type. So this can be done here. If we auto generate the load combinations, then this is automatically done by the program. Then we have the partial safety factors for materials. So in here we have the partial safety factor for material properties. Before that we will see the selection of the design code. So here you can select the design code to be used for the design, and at the moment along with the recommended values the program supports the Italy as well as the Sweden annexures, but in the next version the program will be also be supporting the Singapore national annexure. After that we have the partial safety factor for materials. So here we can specify the partial safety factors for materials. You can automatically update the partial safety factors as per the code, but if you want to manually edit these partial safety factors, then that can also be done. Then as I mentioned that the program is capable of both design as well as checking. So let's see that what is the difference between the design and checking. If we perform concrete code design, then the program will recommend us rebars depending on the code. So as per the specifications of the code, the program will recommend us some rebars. But if you want to change the rebar data as per your own will, then you can change the rebar data and then you can perform the checking, concrete code checking, to see that the modified rebar data is appropriate for that section or not. So for that rebar data, the program will apply the ultimate limit state as well as the serviceability limit state checks for the section. So the program supports the Eurocode specifications for flexure design as well as for the axial design. So for the axial design, the program first calculates the allowable slenderness limit, and then the program calculates the slenderness for all the elements, and then it decides if the element is slender or not. If the elements are slender, then the bending moments are magnified. So for the magnification of the moments, two methods are available in the program. Either you can perform the second order analysis and then get the magnified moments from the analysis itself. If you do not want to perform the second order analysis, then the program will magnify the moments depending on the Eurocode recommended method. Then after that, for the design of columns, the program provides the PM interaction curve. Then for the design for shear, the program calculates the shear stress for a section, and then it compares the shear stress with the allowable shear stress for concrete. If that is not satisfied, then the program calculates the shear reinforcement and the spacing is also calculated. Along with this, the program take care of the codal specifications for the maximum and the minimum area requirements and the maximum and the minimum spacing. So this is taken care for both beams as well as the columns. And for wall design, the program also applies these specifications. Now let's see the design in Midas Gen. So here we can select some partial elements to be designed, and then we can go for concrete code design, beam design. So here we have the results sorted as per member and as per property. So if we sort the results as per member, then different reinforcement will be assigned to each and every member. But if we go for as per property, then the same reinforcement will be assigned to all the members with the same section size. So we have the results in the tabular form, and also we have the design reports. So the program provides two design reports. First is the quick summary graphic report. So in the quick summary graphic reports, the program provides the section diagrams and then the values of the required bending moment capacity, the factored strength, and the ratio for the both. So this is done for both positive as well as the negative bending moment, and then for shear. And the second we have is the detailed design report. It is a very detailed report. In this report, the program first gives us the information about the load combinations, then the information about the beam design is reported. So first we have the information regarding the beam section, then the material information is detailed. After that, the design forces are written, and then the reinforcement information is given. After that, the program also details regarding the calculation steps, the neutral axis and the capacity of the section, and then the check ratio. So this is done for both positive as well as negative bending moment. Then we have the shear capacity and the required shear force, and then the ratio between both. So if shear reinforcement is required, then the program will also provide the shear reinforcement and the spacing will also be calculated. Otherwise, the nominal shear reinforcement will be provided. Similarly, we have the beam design. Similarly, we have the column design. So here we have the graphic report. So we have the PM interaction curve. So we saw that how easily we can obtain the design results and how detailed design results are. So in this way, the program results come out as if they are not from a black box. Then let's see how we can perform the checking. So for checking, first we need to specify the data, the reinforcement data. So we have assigned some rebar data to both beam as well as column. Now let's see that how we can perform the checking. So for checking, first we need to change the rebar data. So here we have two bars at both top and bottom. So we want to change it to 3 and 1. So I replace the beam data the beam rebar data. Now let's perform the check. So now when I perform the check, here we have the results with us. So since I modified the beam rebar data, so the section comes out to be unsatisfactory. The section design comes out to be unsatisfactory. So we need to change the beam rebar data. So here we change the beam data, rebar data from 2 at the top and 2 at the bottom to 1 at the top and 3 at the bottom. So these effects are reflected in checking. Now, section for design. Suppose you perform design for a certain member and the design result come out to be as not good. So in that case, what first thing will come to your mind is go to the pre-processing mode, modify the beam size and check if the modified size is okay or not. The modified size may come out to be okay or not okay. In case it is not okay, then you have to go back to the pre-processing mode and change the beam section size and then see if it is okay or not okay. So this basically wastes a lot of time. So how Midas Gen takes care of is that the program provides an option called section for design. So here we have the section for design. So let's see how we can save our time using this. So here my column section size is 0.2 meter by 0.2 meter, that is 200 mm by 200 mm. So I want to change it to 400 mm by 400 mm. So this column information was changed. Now let's perform the design for this column. So when I perform the design, you can see that the BC and HC are reported as 400. So the program calculated the capacity of the section with the section size specified. So now it is coming out to be okay. So you need not perform the iteration. So in this way, you need not go to pre-processing mode each and every time, change the section size and then perform the design. You can change the section size in the post-processing mode itself. Now let's see the meshed slab and wall design in Midas Gen. So for the meshed slab and wall design, the program performs the slab flexural design. The slab flexural check is also performed. The program also performs the slab serviceability checking. The punching shear check is also performed, and then the wall design is also supported. So for the slab flexural design, the program gives us the following outputs. We can have the outputs in the form of rebar spacing and diameter, required rebar area, required rebar ratio, that is the ratio of area of rebar to the area of section, and then we can have the resistance ratio, and we can also have the wood armor movements. And then the program offers the subdomain. Let's see where is the subdomain useful. So here we have a structure. We'll perform the slab design for this. Let me activate a typical story. So here we have a story and we will perform the slab design for this. So here we have the options for meshing. So the program can auto generate the meshes, and then we also have the domain. So here let's see what is the use of subdomain. So here you can specify that in one subdomain you want the reinforcement parallel to x-axis and the second direction is at 90 degrees from the direction 1. That is, one of the reinforcement is parallel to x-axis and the second reinforcement is parallel to y-axis. But in the other part of the slab, you do not want this. You want to provide the reinforcement at an angle of 45 degrees from the global x-axis, and the second direction of reinforcement should be 90 degrees from that. So here you can specify the direction of the reinforcement. The program uses the wood armor movements for calculating the required movements in the direction of the reinforcement specified. Let's see flexural design of slab. So in design we have the mesh slab and wall design. So here we have the meshed slab or wall load combinations. The reason we have provided this option is that sometimes the engineers do not want to perform the slab design for the lateral loads. So here you can make a choice that for a given combination you want to perform the slab design or not. Similarly, you can specify the combinations for the serviceability checks, the deflection check, and the wall design. And then you can specify the design criteria for rebars. Here you can provide the basic rebar for the slab. So when you provide the basic rebar for the slab, then that reinforcement will be provided in the entire slab, and if at any other place the additional reinforcement is required, then that will also be provided. Now let's see the slab flexural design. So here I select some part of the slab and I want to see the wood armor movements. So here for the selected part we have obtained the wood armor movements. I'll activate this much part. So here we have assigned the rebar to the slab. Similarly, we can have the checks for the resistance ratio. So here I would also like to mention that regarding the results of the design for slab, we can have the contours and we can also have the design force in the form of a table. So here the program can list that what is the most critical moment for design, and the wood armor results are tabulated. Along with this, the program also provides a detailed design report for the slab design. So here you have the design forces, the material information, and then how the program analyzed for flexure and what reinforcements are provided, and the check ratios. After that, we'll see the slab shear checking. So for slab shear checking, the program supports the shear check using the stress as well as using the forces. So for the stress, the program will obtain the stresses from the analysis, and if you want to have the check as per the force, then the codal provisions will be used. So let's see first as per the forces. So in the forces, the codal provisions will be used. So here we have first the stress checks. So for the punching shear check, the program will give a detailed design report that which is the control parameter and if there is a requirement for reinforcement or not. And then the program will also perform the punching shear check at the column face. So here we have the results as per the forces. So the program detects that where is the column located, and then the results are obtained. So the detailed check report is also made for this. So for punching shear check, the code specifies different beta factors for the edge column as well as the interior columns and the corner columns. So the program takes the corresponding beta factors. So we have a detailed design report for punching shear check as per the force method. Now let's see the slab serviceability checking. So the serviceability checking is supported for stress check, crack width, and deflection check. These three serviceability limit states are specified by the Eurocodes. So for the stress check, so you can obtain the stress contours. So here we have the stress contours. And then we have the crack control serviceability limit state. So here we can check the crack width. So here we have the crack width result. And the program also supports the deflection check for the cracked section analysis. So you can perform the cracked section analysis and check the deflection. And for the serviceability limit states as well, the detailed design report is prepared by the program. So here we have the detailed design report for the crack check. Now, as I mentioned, the program calculates the changed moment of inertia by crack section analysis, and then the deflection is calculated, and then the program supports the wall design. Let's see the wall design feature of Midas Gen. So here you can perform the wall design. So similarly, the results can be obtained in the various forms. The design force in the table form and the design result report in the form of text report is prepared. So for wall, the program checks both the vertical as well as the horizontal reinforcement. Then let's see the capacity design. So the program supports the capacity design as per Eurocode 8. So you can have the strong column weak beam design. So in order to perform the capacity design, the program first performs the beam design, and from the design moments of the beams, the program calculates the minimum required design moments for the columns. So this ensures that the ductility design is performed. Similarly for the shear forces and for the wall. So for the wall, first we need to classify the system as the wall system or the dual system. Wall system is one in which the horizontal forces, that is the lateral forces, are resisted by the walls only, and the dual system is one in which the lateral forces are resisted by both the walls as well as the frame. Let's see capacity design in Midas Gen. So here we have a structure for which we'll perform the capacity design. So if you want to perform the capacity design or not, that can be specified in the concrete design code. So here you can specify that what should be the ratio of sum of moments of columns to the sum of moments of beams at a particular joint. And then you can simply go for ductile design. So when you go for ductile design, the program first calculated the design moments for beams, and then using those moments the program calculated the design moments for the columns, and then the results are presented. So here we can check the ratios. So as soon as you go for this, here you can check that at certain joints the design moment of the columns are less than the required. So here you need to change the sections, and this information is also presented in the form of tables. So here you can specify the acceptance criteria and see that at what joints the column sections are inadequate. Now after this, let's see about Midas Dshop. Let's see that how the program is capable of generating the structural drawings. So Midas Dshop offers the plan drawings, the elevation drawings, and it also supports the auto generation of the beam detail drawings and the column detail drawings. So you can have various formats of the beam detail drawings. Let's see Midas Dshop. So here we have a structure in which we have some beam rebar data and column rebar data specified to various members. Now here we can import this information in the form we can export this information in the form of Midas drawing file. So we converted this information, and after that we can use Midas Dshop. So here we can import the information obtained from Midas Gen. So here we have all the information imported. So the program imports the required rebar area as well as the rebar sizes. If you want to change the rebar sizes in Midas Dshop, then it can be done. Then in preferences, you can specify the various specifications for drawings, the rebar sizes you want to use, the Eurocode, uh, the code as per which you want to perform the detailing. And then in the design code, you can specify the beam rebar list type. So what drawings you want to have for beams. So the program offers 5 options for the different beam drawings, beam detail drawings. And then we have the plan view drawings. And similarly the sectional view. So the sectional view can be obtained in both perpendicular directions. Now let's see the detailed drawings considering the reinforcement. So here you can specify the size of the page of the drawing, and then you can have the detailed drawings for plan and similarly for sections. Now let's see the member rebar info. So here we have the beam rebar info. So at each and every floor you have the beam section sizes, the information about the top and the bottom rebars and the stirrups, and similarly for columns. And then for girders. So detailed drawings can be generated, and these drawings can be generated as DWG and DXF format, and also the longitudinal sections for columns are generated. So here you can have very detailed drawing of column. Now let's see the general section designer, which is an additional tool in Midas Gen for the irregular section shapes. So let's see the general section designer. So here we have a structure in which we have all the rectangular columns. But let's say for this column you want to use some irregular section. So let's go to tools and general section designer. So The general section designer supports the import of AutoCAD DXF files. So if you have some section in AutoCAD DXF format, then that can be imported to Midas GST and then finally to Midas Gen. So here you add some material for this section. But first we need to change the units. So now we'll import the DXF file for the section. So here we have the section shape imported. So here we can specify the mesh size. So the program calculates the section properties depending upon the mesh size. And then we can link the two programs, Midas GSD and Midas Gen. And then this shape can be exported to Midas Gen. So here we have the shape with us. Let's import the shape again. So here we export this shape to Midas Gen. So here we have a new shape added. So we'll assign this shape to this column. So here we have the change shape. So from AutoCAD DXF file, we have the shape in Midas Gen. Now we can perform the analysis for this. And then we have the design results with us. We have the analysis results with us. And then we can import the analysis results in Midas GST for the design of this section. So for that, we'll just import. So we can specify that what load combinations data we want to import into Midas GST. So here we have the shape with us. Now we can specify the reinforcement. So here we have Eurocode. So I'll go for class A rebar grade and then the distribution of the reinforcement. So we have the rebars. Now we can analyze this. So here, as soon as we perform the design, we have the stress contours as well as the PM interaction curve. And the stress contours for the load combinations. So we can select if we want to see the contours for the axial force, My, Mz or combined. And then these results can be exported to Microsoft Excel very easily. So here we have this report with us. So the first program list the section properties, material properties, and the load combination information, then the PM interaction curve. So this was about Midas GSD. So how we imported the AutoCAD DXF file to Midas Gen via Midas GSD, and then we designed the section. Now let's see about the BIM capabilities of Midas Gen. So the program is capable of import and export of information from Revit structures. Let's see how we can import and export information from Revit. We have a column with size 350 mm by 500 mm, and then we have the slab with thickness of 250 mm, and we have beam elements with size 500 mm by 500 mm. Now when you will install the interface between Revit structures in Midas Gen, then you will get an option to send the model to Midas Gen under external tools. So you can select the fineness of the mesh to be generated for the slab elements. So you have the message that for the confirmation that sending Revit model to Midas Gen has been done. Now let's open a new file in Midas Gen and import the file. So here we have the information imported. So let's check the section sizes. So here we have the beam sizes 500 mm by 500 mm. Let's change them to 450 mm by 400 mm. And then we have the columns 500 mm by 350 mm. Let's change the size to 400 mm by 400 mm. And similarly change the thickness to 80 mm from 250 mm. So this is done. Now we will generate a MGT file. So this MGT file will be replaced, and then we will export this information back into Revit structures. So as soon as we click on update, the information will be updated, and we have update summary with us. So here the program mentions the number of sections and thicknesses that have been modified. So now let's check the new section sizes. So this is the updated column size 400 mm by 400 mm, and similarly the updated beam size 400 mm by 450 mm, and the slab thickness has also been updated from 250 mm to 280 mm. So this was all regarding today's webinar. If you have any questions, then please feel free to write the questions in the questions window.